Hello students, here is Shittu, your mathematics teacher. This lesson is brought to you by IOTA Virtual Learning. So in this tutorial today, we are going to be solving WAEC questions on differentiation. So we have the first question here. So if y equals parenthesis 1 plus x all squared, find dy dx. And we are given these options. I would like you to pause the video, do it yourself, then come back and check your result. So we have y solution. We have y to be 1 plus x all squared. And the question asks us to find dy dx. So which means we are going to be differentiating y with respect to x. So now as we can see, we have what? We have 1 plus x inside, we have 1 plus x there all to the power of 2. So now what we're going to do here is that we let u to be 1 plus x, the one inside the parentheses. So we're going to have du dx equals, now differentiating this, we're going to have what? We're going to have 1. If we differentiate 1, will give us 0 because the derivative of a constant number will give 0, then this will be 1. Are you getting it? So from there, the next thing we're going to do is that come from here, from the function, we have y equals 1 plus x all squared. So we can see that this will lead to, we have 1 plus x to be replaced by u, we're going to have u squared. Then from there, we are going to differentiate this y with respect to u here. So this is going to be dy du equals, so 2u, then 2 minus 1, and that will lead us to 2u. 2 minus 1 is same thing as 1. So we have dy du to be 2u. Now, what is the next thing we're going to do? This one here, okay, let me call it A, and this one here, let me call it B. So we are going to use what we call chain rule, okay, chain rule. So this chain rule is what we are going to use to find the dy dx, and chain rule states that dy dx equals dy du multiplied by du dx. And as we can see, dy dx is what we are looking for. That is dy dx equals dy du is already here, which is the b. So we're going to have 2u multiplied by du dx is 1. So if you multiply 2u by 1, so you're going to have 2u. Now, this is not where we are going. So we have u here. This u here is what? Is stated here to be 1 plus x. So we're going to replace it. So by replacing the value of u, we're going to have 1 plus what? 1 plus x. So we have 2 into bracket 1 plus x. And this can also be simplified by multiplying these two by what you have here. 2 times 1, we have 2, plus 2 times x, we have what? We have 2x. Now looking at the options up here, so we can see we have the option B to be the what? To be the solution, which is 2 plus 2x. We have the second question here. If y equals x cos x, find dy dx. We are given these options here. So I would like you to pause the video, do it yourself, and come back and check your result. Now here, given y to be x cos x. Now here, this function, you can see we have x and we have trigonometric function. Therefore, we have the product of two different functions. So when you have that, so the formula we are going to use, we're going to use product rule. And the product rule states that the product rule is this: dy dx is going to be u dv dx, this is u, and plus v du dx. So now I'm talking about u, I'm talking about v here. So now my function, let u be x and v be cos x. So therefore u is one function and what, and v is the second function. So now when you have this, and you can see this is the product, what you're going to use here, if you look at this product rule, we have dv over dx and we have du over dx. So which means from here we're going to have what, we're going to have dy dx from what we are given here. Using this formula, what is my u is x, I will keep x, then dv dx, I'm going to differentiate this dv differentiate v with respect to what, x, and that's going to be multiplied by minus sine x. So now because the derivative or the when you differentiate cos x is going to give us minus sine x. So we have that, then plus you keep v this time around, which is cos what, cos x, then multiply by du dx, you differentiate x. If you differentiate u with respect to x, we're going to have 1. Okay, so we have this to be x times this will give us minus x sine what, sine x, then plus what, plus cos x. So we have minus x sine x plus cos x. We can rewrite this as cos x coming first, then taking this after. So we have this, we have cos x minus x sine x. Then looking at the option, we have option what, option D to be the what, to be the solution to the problem. Thank you. We have the third question here. The question says find the derivative of this function. We are given this function and we have the options here. Solve it on your own. Pause the video, solve it, then come back and check your result. So now here, solution. Since we have y to be x to the power of 7 minus x to the power of 5 over x to the power of 4. Now from here, we can rewrite this function as y before doing before differentiating this function. So let us reduce it to its simplest form. X to the power of 7, we can see that this can be splitted as x to the power of 4 minus x to the power of 5 divided by x to the power of 4. So from here, we have what, we have y to be now x raised to power 7 divided by x raised to power this. So we can see that we're going to remove 4 from this 7 because of this x to the power of 4. We're going to have x to the power of 3 minus here, remove 4 from here, that is from the law of indices. So remove 4 from here, we're going to have x. Okay, so you can see that we reduced this to its simplest form. So now from here, just do the differentiation. So differentiating y with respect to x. So this is going to be 3x squared. You just remove 1 from 3 and multiply the 3 by this, then minus, we have what, we are going to, this is going to be 1. So therefore we have what, we have the solution to be 3x squared minus 1. So now looking at the option, we can see we have the option what, option C to be the answer to the problem. Thank you. So we have question number 4. If y equals 3 cos 4x, dy over ds equals to what? Equals, we have a, we have all of this. Now pause the video, do it yourself, then come back and check your result. So y is equal to 3 cos 4x. Now from here, we have 4x here. So this 4x, we're going to use a chain rule or function of function. So we're going to let u to be 4x. Okay. So now if u equals 4x, just differentiate u with respect to x. We're going to have what? We're going to have 4. Okay. If you differentiate 4x, you're going to be having what? You're going to be having 4. And from the function, after replacement, you can see that y now for u, we can have y to be 3 cos u now, because we've already replaced this 4x by what? By u. So we have this. So now since you can now see that here the right hand side is now what? Is now purely a function of u. So you're going to differentiate dy. I mean, you differentiate y with respect to u, and that's going to be 3 minus sine u. 3 minus sine u, because the derivative of what? The derivative of cos u, that is when you have dx of cos, let's say cos a, okay, this is going to be minus sine a. Do you understand? So that's what we did here. Okay, so now dy du is going to be, you multiply this by this, you're going to have minus 3 sine what? Sine u. Understood? So now from here, now it is not, we now have to populate this we're given. We have du dx, this one and this one here. So we're going to put it in the function, that is chain rule, dy dx. What we are looking for is same thing as dy over du, then multiply by du all over dx. Are you following? So now from there, so dy du, we have it to be minus 3 sine u, then multiply by du dx is what? Is 4. Now from here, you can see this is multiplication. Now 4 times 3, you're going to have minus 12 sine what? Sine u. But we are having u here, so we need to recall that we have what? Recall that u equals what? U equals 4x. So now you're going to replace it here. You're going to have minus 12 sine what? Sine 4x. And that is our solution. So we have minus 12 sine 4x to be the solution. Now looking at the option we have, so we can see that we have the option D to be the solution. Thank you. We have question number 5. Find the derivative of sine theta over cos theta. So now if you can do this, kindly pause the video, do it yourself, then you can come back and check your result. Okay, so since this function, let's represent this function to be y equals sine what? Sine theta all over cos theta. So now since this involve fraction, so we're going to use quotient what? Quotient rule. Okay, quotient rule. And the quotient rule states that if you have dy dx, okay, is going to be v du over dx minus u dv over dx divided by v squared. So that's the formula for the quotient rule. Now which means this v and u, we're going to get the v and u from here. We let the function, any of the function, let's take this u to be sine theta. Okay, if u is equals sine theta, then you can see that we have what? We have since it's theta is what we are looking for here, the independent variable here is theta, so we can replace this, okay, to dy d theta, okay, d theta, and this what? D theta. Are you getting it now? So which means we're going to get du d theta from here, and the derivative of sine theta is what? Is cos theta. So we replace v to be cos theta, and we're going to find dv d theta, which is going to be minus sine what? Minus sine theta, because the derivative of cos theta will give us minus sine theta. Now we have this, we have this, we have this, we have this. What we need is to put all of this into what? Into the main or given so this should be like this: dy d theta equals this is how it should be. So now you're going to have dy d theta, okay, because here it's not going to be dy dx because the function here, all these functions are functions of theta. So we're going to have this. So this is going to be v, we keep v. What is v? Cos theta. Then the derivative of du d theta, which is this, we have cos theta, okay. Then minus, we have u. What is u? U is sine theta, okay. Then multiply by, we are using this now, dv d theta, which is sine theta, okay, minus sine theta. Understood? So all divided by v square. What is my v? The v is this, we have cos square theta. Are you following? So from there we have dy d theta to be equals cos theta times cos theta, that will give us cos square theta. Then minus minus will affect, we're going to be plus, that is minus times minus. Then we have sine square theta all over cos square theta. Now look at this numerator here. So you need to recall that sine square theta plus cos square theta is equal to 1. So you need to know that it's a trig identity. So now here we have cos square theta plus sine square theta here. That's going to be 1 all over cos square theta. Then also you need to recall, when you have sec theta, the theta is what? Is like reciprocal of what? Theta. So therefore look at this, SEC coming to the third letter here. This is going to be 1 over the third letter, that is C, and that is cos. We have cos theta. So if you now have sec square theta, you know that this is going to be 1 cos square theta. 1 cos square theta. So from here you can see that we have 1 cos square theta here, and that's going to give us sec square theta. So we have what? We have the dy d theta here to be sec square theta, and that's the option what? Option A to be the solution. We have the question 6. The question says find the derivative of the function y equals 2x squared into bracket 2x minus 1 at point x equals minus 1. So we are given these options. So now let's see how we're going to solve this. But before that, kindly pause the video, do it yourself, and join the class again to check your result. We have y equals 2x squared into bracket 2x minus 1. So now from here, so what I'm going to do here is that I'm going to use this to open the brackets. That is, I will use this to multiply this. We can have y equals 2 times 2, we have 4. X squared times x, that will be x to the power of 3. Then minus 2x squared times this, we're going to have 2x squared. Right? So now we can now differentiate this, okay, directly by having dy dx is going to be, now this 3 we have to multiply the 4, then x, then we remove 1 from 3, we're going to have 2. Then minus this 2, we multiply this 2 times 2, then x minus 1 from 2, we're going to have 1, so we have that. Then we have 3 times 4, that is 12x squared, minus 2 times 2, we have 4x. So this is the differentiation. Now, but they say at point x equals minus 1. So now, at point x equals minus 1 means whenever you see x or wherever you see x, okay, you replace it with by minus 1. So I'm going to have dy dx at what? At x equals minus 1 is going to be 12 into bracket minus 1 all squared minus 4, then minus 1. Okay, so we're going to have this one is going to be, we're going to have this to be 12 times this minus 1 squared is going to be 12. We have 12 minus times minus, that's going to be plus we have plus 4. So 12 plus 4, we are going to have 16. So now let's see whether you're going to have what? We're going to have our result to be 16. So looking at the options, so we can see we have option B to be the answer. Question number 6. If y equals x to the power of 3 plus 3x squared, find 2 dy dx minus x d square y over the x squared. So we have these options. Now you can pause the video, solve it yourself, then come and check your result. Now we are going to solve this solution. I'm going to rewrite the function given to be s cubed plus 3s squared. So if y is this, we have this function here, but the question said we should find dy dx and d square y dx squared. So now to find the dy dx, so it means we're going to differentiate each of the terms. Now before that, I would like you to remember that if you have a function of this nature, that is y equals x to the power of n, the dy dx of this function will be n. This n we have to multiply, then remove 1 from this n. So this is how you are going to solve the type of, to solve for dy dx. So n will come down, then remove 1 from it. So that is what we are going to do here. Now you can see if you want to do this, 3 will come down, then multiply. This is a dot multiplication, x to the power of 3 minus 1. We use this plus, now 2 times 3, 2 times 3, then x to the power of 2 minus 1. Can you see? So now from there, we're going to what? We're going to have this to be dy dx is now going to be 3x to the power of 3 minus 1, going to have 2, plus 2 times 3, we have 6x, then 2 minus 1, we are going to have 1, and x to the power of 1 is same thing as x. So we have that. Now from there, that is the first thing we're going to do, which is dy dx. Now we need the square y all over dx squared. So it means that this dy dx, we're going to differentiate this again. So now the same approach, 2, we multiply this, 2 times 3, then x, 2 minus 1, plus 6. You know that ordinarily x is having power 1. So if 1 is multiplying this, you remove 1 from it. So we're going to have 2 times 3, we have 6x, 2 minus 1 is 1. So we're going to have 6x, then plus 1 times 6 is 6. 1 minus 1, that will give us x to the power of 0, and any number raised to power 0 is what? Is 1. So we're going to have this to be this. So we have the square y over dx squared to be 6s plus. Now, what they ask us to find, so we're going to have 2 dy dx minus x d square y over what? Over dx squared. So this is going to be 2 dy dx we are given is what? Is this, what we have, which is 3x squared plus 6x. Are you following? Then minus the x into bracket d square y dx square, d square y dx squared will give us 6x plus 6. All right, so from here, try to open the bracket. 2 times this, we're going to have 6x squared plus 2 times 6x, we're going to have 12x, and minus x times 6, we're going to have minus 6x squared, and minus x times this, we're going to have minus 6s. Now looking at this, we have 6s squared there, we have 6s squared there. So this, we cancel this because it's going to be 0. 12x minus 6x, we're going to have 6x. So therefore, we can see that all of this here equals what? 6x. So now looking at the options we have, we can see we have the option B to be the solution. All right. So now that's the end of the class for the first video under this differentiation. So kindly check your past question series. Look for differentiation questions. With this knowledge, I believe you're going to get the differentiation problem very easy to solve. Thank you. Bye bye.